Hello and welcome to class. So today we are going into day 2 of Unit 6, the notes on slopes and parallel perpendicular lines. And this is a topic that we talked about last semester that we talked about it right at the end. So we're just going to kind of review it again and kind of dip our toes into our new semester, kind of a little bit slower. So our objectives today are that students will be able to find the slope of a line, then find a parallel or perpendicular slope. Our language objectives are that students will use tables to find the slope of a line, then use properties of parallel and perpendicular lines to find the corresponding slope. So parallel lines are lines, if you recall, that never intersect. And because they never intersect, that means that they have slopes that are the same and their y-intercepts are different. And it's important to note that the y-intercepts are different because if they have the same slope and the same y-intercept, then in essence, they're the same line. So that is why it's important to note that different y-intercepts piece of the definition. Remember that perpendicular lines are lines that intersect to form right angles. And they have slopes that are opposite reciprocals, which remember is just a fancy way of saying flipped with different signs. And then the slopes of perpendicular lines have a product of -1. So we're going to use these definitions to help us find slopes. So this first part, we're just going to find our slopes at these 2 points. There's a couple of ways that you can find the slope of a line. And one way that we've used a lot in class is to make a table. So we put all of our x's on one side and all of our y's on the other. And then we just kind of look and we say, okay, how am I going to get from 1 to 5? And the difference between 1 and 5 is that we add 4. And to get from 2 to 4, that is adding 2. Remember that we've talked about slope as being rise over run. And then you can also think of that as your change in y over your change in x. And that triangle is a symbol that we use in the math world that means change. So we want to look at the change in y over the change in x. So our slope will be whatever's y change was, which was 4, over the change in x, which was 2. Then remember, you always want to simplify your fractions. So 4 over 2 is 2. Since it's a positive slope, then we know that this line is rising, or has, since it's positive. The other way that you can find the slope is to use the slope formula, which is m equals y2 minus y1 over x2 minus x1. And so for this one, -1 is x1, 0 is y1, 3 is x2, and -5 is y2. It doesn't so much matter which one you label as 1 and 2, but it does matter the order you put them in the fraction. So whatever order you put on top should also follow on bottom. So if I do -5 minus 0 on top, I need to start with 3 on the bottom and minus the -1. And that's what makes the formula a little bit trickier than using the table. So then -5 minus 0 gives me -5. 3 minus -1 gives me 4. So that is simplified. So that is my slope. So m is equal to -5 over 4. Since it's negative, I know that is falling. So you can choose to use whichever method you want to use. I prefer the table because I don't have to worry about order and I don't have to worry about the formula. I can just kind of put them in a table and go for it, which makes it easier for some people. When we look at C, 2, 1, -3, 1, looking at my change, 1 to 1 is just adding 0, and 2 to -3 is adding 5, or subtracting 5, sorry. So that slope is going to be 0 over negative 5. Well, if I have nothing and I divide it by negative 5, I'm going to be left with nothing. So this line is what we call a horizontal line. And that's because it doesn't have any change in the slope. So if I were to graph those 2 points, come over here and make a little graph, at 2, 1 or negative 3, 1, it doesn't go up any, it just goes straight over. When we look at D, making our table, negative 1, 2, and negative 1, negative 5. From 2 to negative 5, I'm going down 7. We go 2 to 0, and then 0 to negative 5 is a total of down 7. And negative 1 to negative 1 is a change of nothing. Again, we put the change in y on top, change in x on bottom. Well, now we have a 0 in the denominator. So you're imagining you have 7 cookies and you're dividing them amongst 0 people. Someone has to have the cookies. So we can't divide by 0. So that is what we call undefined. And that line is vertical. So if I were to graph those 2 points, I would go to negative 1, 2, and negative 1, negative 5. Those points are going straight up and down. It's an undefined slope because if we think about it, that's not a function. So if you think back to Unit 3, it fails the vertical line test, which makes it not a function. Hence why we call it undefined. Because they form a line and it will have similar qualities of a line. We can write an equation for it, but it's not a function, which is why we call it undefined. Now we're going to use those slopes from part 1 to create parallel and perpendicular slopes in part 2. So I'm just going to take all of my original slopes. So my original slope for A was 2, for B was negative 5 over 4, for C was 0, and for D was undefined. So parallel slope means that it's going to stay the same. So my parallel slope is just whatever my original slope was. So my original slope was 2, my parallel slope is 2. The perpendicular slope, we need to flip the fraction and then change the sign. So 2 is a whole number. To think of that as a fraction, we're going to put 2 over 1. So the perpendicular slope will then be negative 1 over 2. I flip my fraction and then I change the sign. Negative 5 over 4 is a little bit easier, so my parallel slope is going to stay the same at negative 5 over 4. My perpendicular slope, I'm going to flip my fraction, so it's 4 over 5, and since it was negative, my answer is going to be positive. Remember, if you multiply those together, negative 5 over 4 times 4 over 5, multiplying the numerators, you get negative 20. Multiplying the denominators, you get 20. Negative 20 divided by 20 is negative 1. So we get that negative 1 that we wanted as the product. Looking at C, my parallel slope will be the same, so it'll be 0. But then my perpendicular slope, how do I flip 0? So if we think about it, this is 0 over 1. So when I flip it, it'll be 1 over 0. We can't divide by 0, and we know that when 0 is on bottom, then we know that it is undefined. You can also think about the fact that something that has a 0 slope is a horizontal line. The line that'll be perpendicular to that would be a vertical line, which is undefined. And lastly, for D, our parallel slope will be the same, so it'll also be undefined. Kind of looks like an 11 instead of my parallel. And my perpendicular slope, well, if undefined is perpendicular to 0, then perpendicular to undefined would be 0. Before we get into part 3, I want to show you this graphic organizer that you're going to have access to in Google Classroom. This will help you when you're determining if lines are parallel, perpendicular, or intersecting. The first thing you're going to want to do is make sure that you find the slope of each line. So figure out your slopes. Then you're going to think, are my signs the same? So are they both positive? Are they both negative? And then depending on your answer, you'll follow that part of the tree. So if your signs are the same, then you're going to think, okay, are my numbers the same? And if the numbers are the same, then you know you have parallel lines. If they're not the same, then those lines are just intersecting. They're not perpendicular, but they're intersecting because those two numbers are not exactly the same. If your signs are not the same, so they're different, then you want to think, okay, is the product -1? Or you can even think, are they opposite reciprocals? We already know the signs are different. If they're reciprocals of each other, then they would be perpendicular. If they're not, then it is just intersecting. So if the lines are not parallel or perpendicular, then they just intersect each other. So they might look something like this, where we can see that that's very clearly not perpendicular lines, but they are not parallel either. So we can kind of refer back to this when we are looking at these examples in part 3, where we want to determine if they're parallel, perpendicular, or intersecting. So when we look at the first line here, we see that we have y equals 3x plus 4. Remember that y equals mx plus b is slope-intercept form, where m is our slope and b is our y-intercept. So since m is our slope, the 3 is our m, so our slope is 3 for that first line. For the second line, we see that we have a 3 on the x, so our m is 3. This is easy to see that those two slopes are the same, but if you're using our little guide, are the signs the same? Yes. Are the numbers the same? Yes. So that means that they are parallel. Let's actually jump over to D and do D next. So when I look at this first line, I see that the number on x is -1/3. So my m is -1/3. And then when I look at the second line, I see that on the x, I have a 3. So that means that my m is 3. When I go down, ask myself my questions. Are my signs the same? No. Are the numbers, do they multiply to be -1, or are they reciprocals? So if I do -1/3 times 3, remember you just put 3 over 1, so -1 times 3 is -3, 3 times 1 is 3, -3 divided by 3 is -1. So that means that, yes, this product is -1, so these lines are perpendicular. Looking at B, I can see from my first equation, it's in y equals mx plus b form. So I can see that I have a -4 for my slope. When I look at my second equation, I see that it's not in y equals mx plus b form. I have something on my y. So before I can actually finish solving, say what my slope is, I need to divide everything by 4. Which gives me that y is equal to 1/4x plus 3/4. Then I can see that I have a 1/4 on my x, which means my slope is 1/4. When I compare my two slopes, I have signs that are different. And if I do -4 times 1/4, I get -4/4, which is -1. So those lines are perpendicular. Now let's look at C. We see that our m is 2 here, and our m is 5 here. So they're the same sign, but those numbers are not the same. So these lines are intersecting. Try and do E and F on your own. You should have solved the second equation in E to get that y equals 3/5 x minus 2, giving you a slope of 3/5, noticing that both lines have the same slope of 3/5, which makes them parallel. And the same thing for F. Y equals 4 is a slope of 0. Y equals 3/2 is a slope of 0. Because they don't have an x value, 0 makes it go away, which makes those two lines parallel as well. Part 4 is the most work intensive, but it's not too difficult. So we're still deciding if the pairs of points are parallel, perpendicular, or intersecting. So to do that, the first thing you need to do is find the slope of L1. I'm going to use a table because I think it's the fastest. So L1, we have a change of 1, of a subtracting 1 over adding 2, which gives me a slope of -1/2. For L2, I have the points 0, -1, and 2, 0. So -1 to 0 is adding 1. 0 to 2 is subtracting 2. So my slope is 1 over -2, which is the same as -1/2. So I can see that my two slopes are exactly the same, which makes these two lines parallel. Looking at B, I'm going to use the same strategy. I'm going to find L1 first. So L1, I get 0, 3, 3, 1. So to get from 3 to 1, I minus 2. To get from 0 to 3, I add 3. So my slope is -2 over 3. For L2, making my table, get -1, 4, -7, -5. So from 4 to -5, that's minusing 9. And from -1 to -7, that's minusing 6. So my slope will be -9 over -6. 3 divides into both the top and the bottom, which gives me -3 over 2. Oh, sorry, negative divided by negative makes that a positive. So it's +3 over 2. We can see that our signs are different and that they are reciprocals. But then remember, you can also check, is -2 over 3 times 3 over 2 -1? So -2 times 3 is -6. 3 times 2 is +6. So -6 divided by 6 is -1. That is what we want. So these two lines are perpendicular. You give number or letter C a try. You should have found that your slope for line 1 was -2, your slope for line 2 was -2, and since those are the same, that makes those two lines parallel. I will be answering any questions in class and going through these notes again. So if you have questions, be sure to ask them, and I will see you later. Have a great day.